Welcome to the video for Chapter 11, Lesson 1, Parts of a Circle. In this lesson, we will answer the question, what are the different parts of a circle? Let's identify some of the basic parts of the circle, and we'll start by naming it. A circle is a set of all points in a plane that are a given distance, equidistant, from a given point, called the center. We name that circle by the center, so this one would be called circle D, and we label it with a circle and the dot in the middle with the letter next to it. So this particular circle is called circle D. And with the different parts, DB, I'm looking over here now. DB is a blank of circle D. So DB is a radius. It goes from the center to a point on the circle. We don't say side because technically circles don't have sides. So from the center to a point on the circle is called a radius. The next one, AF, is a diameter. So from one point on the circle to another point on the circle, specifically going through the center, is called a diameter. So point on the circle going through the center to another point on the circle is called a diameter. And the last one, CE, is one point on a circle to another point on the circle, but this one does not have to go through the diameter. And in that case, it's called a chord. Because of the way that the radii are created, all radii of a circle are congruent or the same length. Notice this is the plural word, the plural form of the word radius. So all radii of a circle are congruent or the same length, and the measure of the diameter is twice the measure of the radius. Let's take a look at this example. It says a Mustang GT has 20-inch rims and low pro tires. What is the radius of each rim? The rim is going to refer to the distance across the tire. So in that case, when we're talking about the 20-inch rims, we're really talking about the diameter. And so when we want to know the radius of each, we just take the diameter, divide by 2, and that's going to equal the radius. So 20 divided by 2 is going to give us a 10-inch radius. This one just has a little bit more information involved. It says 4 quarters fit into a square with an area of 23.04 centimeters squared. Ultimate goal is to find the radius. So we're looking to find the radius of one of the quarters. So remember, with a square, the area is equal to the side length squared. So it would be S times S. This side times this side would be the area. So 23.04 is the area. So we're just going to square root both sides to figure out the value of one side. So if we round the square root of 23.04, the calculator will give you 4.8. So that means that instead of an S, I can write 4.8 here. And I'm going to label it down on this side to make it a little easier to look at. So this 4.8 is split really between 4 radii. Okay, so if I only want the measure of one of those radii, all I have to do is divide the 4.8 by 4 to get 1.2, go back to my label, centimeters for the radii, the radius of a quarter. Now let's take a look at a circle with just some basic algebraic expressions for lengths. So I'm just going to go ahead and label the information that I'm given. First, we're supposed to find the measure of the radius, PC, but we are given that it is 3x. So ultimately, we want to find out what that actually is. But PC is 3x, and then the whole way from A to B is 5x plus 6. Okay, so AB is going to be a diameter because it goes through the center of the circle. So that means that if we take 3x and multiply it by 2, if we take the radius and multiply it by 2, that would equal the one diameter. So we're just going to take this and simplify this algebraically. Subtract 5x from both sides, we get x equals 6. So then to find PC, well, PC is 3x, which is 3 times 6, so it's 18. So PC, this length of the radius here, is 18. One other fact about circles is that all circles are similar. Circles in the same plane with the same center but with different radii are also called concentric. So all circles are going to be similar even if they're next to each other. So this circle is going to be similar to this circle. Again, assuming that I was actually drawing perfect circles here, because that would just tell us that there's a relationship with their radius, because all of the radius of every single circle are always going to be half of the diameter. They're all going to be equidistant from the center. Like there's just so much going on similarly that the circles are always considered similar. But these three circles that I drew are just three similar circles next to each other. Circles are considered concentric when they share a center and they're on the same plane, they have the same center, they just have a different length for their radius. So those are considered concentric. So these would all be like maybe circle D as their center, but this would be A, B, C. So my red circles are just random, similar circles next to each other. All three of these circles over here are also similar just because they are circles, but they're specifically concentric because they share the same center point D. These are just some examples of concentric circles you might see: ripples in water, a bullseye, the trunk of a tree, a vinyl record. Those are just some of the many examples of concentric circles. Taking a look at some other solving problems with basic circles. It says circle W has a radius of 15. So this one is circle W, this larger one here. Circle Z has a radius of 10. And they're also giving us that this distance in here, XY, is 7, and we need to find all these lengths. So the first thing I'm going to do is label the information that's given. So if I know that TW is 15 because that's a radius, and ZR is 10 because that's also a radius, and XY they gave me was 7. So if I need to find YZ, this first problem is YZ here, then that goes from here to here. I need this distance. Well, the radius of this circle is 10. So from X to Z, it's 10. And then I know XY is 7. So all I really have to do is 10 minus 7. So YZ is going to be 3. Then what I can do from there, figure out the next one, clear off my circles here. WX is going to be the difference between 15 and 7, because WX only covers to this point here, but from W to Y is 15. So if I take 15 and take away 7, then that's going to give me my 8 for the value of WX. So 8 here, 3 here. And now that I have all that labeled, TX, if we take a look at that, goes from T to W to X. So I'm just going to add the 15 and the 8 together to get that TX is 23. And similar situation with W to R. So W to R, I know each of these individual pieces, 8 plus 7 plus 3 plus 10. We could write all of that out, but if we also recognize that from X to R, it's 20 because the radius is 10. So if I have like just 10 and 10, so that's going to be 20. So I'm just going to write, just to shorten my work up here a little bit, 20 plus 8. So that's going to be 28. But please keep in mind, we could have just started at W and did 8 plus 7 plus 3 plus 10 to get from W to R. And that completes the video for Chapter 11 Circles, Lesson 1 on the parts of a circle. So what are the different basic parts of a circle? The center, the radius, the diameter, and the chord.